video, we worked on our Unity first-person character controller series. In this video, we'll be continuing that series by adding a camera controller that lets us see the point of view of the player. So now, let's get started. Let us open up the Unity project. Make sure you follow all the tutorials before this, and I will put a link to them in the description. Now that this project is open, the first thing we are going to do is open up the camera controller script. Now that it's open, we can see that in the last episode we made a few variables to prepare for coding the camera controller. So in this episode, we're going to right now be using the update function to use these variables. But don't delete the start function because that's going to be used later in the episode. Now, let me show you something. Go to Edit, then Project Settings, then Input Manager, and let's look for two axes, mouse X and mouse Y. Now, so we don't really need the details in here, but just save the name. Okay, so the reason we need the name for this is we're going to be using these two axes because we're going to use this mouse to control the player movement so that the camera can see the player. So we're going to say float mouse X is equal to input dot get axis raw, and this time do use get axis raw because the camera movement should be precise. So then we'll type mouse X in quotes and then multiplied by time dot delta time. And this is the reason why. We're kind of stuck in a problem here because remember what the update problem was I told you last time? That someone with a higher frames per second would get a faster experience because it runs once per frame. And we can't do fixed update, which runs the same for everyone because then it won't be called once per frame. So we have to multiply this by time.delta time because that goes by the time for the person who's playing this game. Because even if different time zones, time goes by in the same time, so this will work for everything. And then we have to multiply by X sensitivity. And then we have to do the similar thing for a float called mouse Y. So you can do this, you can try to do this on your own, but here's how we're going to do it if you don't know. So float mouse Y equals input dot get axis raw, and then do mouse Y, and then times time dot delta time. And then times Y sensitivity. Okay, so now we've made our two axes, the code for the two axes. Now, this code will be a little confusing, so I'll explain it to you after we write it. So, Y rotation is equal to the positive of mouse X, which is written as plus equals, and then X rotation minus equals mouse Y, or the negative of mouse Y. Now this might be a little confusing that why does X go to Y and Y go to X? And the reason is, well, let me show you this. So what you think X rotation and Y rotation is different than what Unity thinks. So let me just run the script to show you what I mean. So let's say we're moving in the X direction. So how do we rotate on the X direction? Because if we're moving in the X direction, we can't rotate the X direction because we just move left and right. So to rotate it, we have to move in the y-axis so that we can go over the x rotation and back. And it's similar for the y thing. So we need the y rotation to be for the x, and then the x rotation to be for the y. So now, so now that's done, now now we have to do one more line of code. So this line of code will be transform dot rotation is equal to quaternion dot Euler. So quaternion is a vector tree, and so quaternion dot Euler is specific to rotation. So it has three parameters: x, y, and z. So we'll do x rotation, y rotation, and 0 because we have no rotation for the z-axis. Okay, so we've programmed the rotation for the camera so that we can rotate to find our player. Now we have to do the same rotation for this player, but we have to make sure that we can't see through ourselves because that would be weird and that we could flip over. So what we have to do to fix that is we have to make a new line for the player and say orientation dot rotation is equal to quaternion dot Euler, and then in the parentheses we would put 0, y rotation, and 0. Now you might be thinking that why we didn't use rb.freeze rotation or rigid body.freeze rotation. The reason is rigid body only freezes the rotation if when we're playing the game and then we rotate because of our actions as a player. But if we say to rotate in this script, it overrides whatever the rigid body says because we're developing this, so our script overrides the rigid body freeze rotation. So that's why we have to do it like this. Okay. And this was what the rigid body freeze rotation would be like. It's switching to render buffer for some reason because I do not have the rigid body variable in this script, but that's how we would write it. Okay, so now if we save this, we could run this and we should see our player rotate it. Okay, so just create an empty parent for the main camera, call it camera container, and then after we name the camera container, attach all of the scripts to the camera container. And also make a child of a player called camera position, or abbreviated to camera pos. You'll see why later. So now we can actually delete this transform camera position variable because we're going to be using it in a different script that we'll make later. Let's save this and we can go back. And that's the only variable that we don't need in the script. Okay, so let's run this. Actually, no, we have to first attach the scripts and then we can run this. So set the transform orientation to orientation, and X sensitivity and Y sensitivity, I'd suggest putting something near 200. So I'll set my X sensitivity and Y sensitivity to exactly 200. Okay, so now we can run this. Okay, so we can see ourselves rotating here, and look, the player is still in front of us. And that's not good because is this really first person? No, it isn't, because we can see the player moving and our camera is not moving to follow him. Look, this player can fall off the edge and I won't even be able to see that. So we need to fix this. So that's where we have to make a new script called camera movement. Okay, so now that we have the script, we can start coding the actual camera's movement so that this camera can follow the player. Okay, so we just have to wait for this to load. And if you're wondering why I'm not just attaching to the camera to the player and making that the movement, is because even though it follows the player, we still get to see the player. So actually by doing this, we will not have to see the player. And it will be a first person experience. So now open this camera movement script. So now that the script is open, we are just going to have two lines of code. So you can delete the start function. So the first line of code is we'll make a serialized field variable called transform.camera position. So I'll just type this script for it and then we'll make this variable. This is editing Racing Gecko. I accidentally made the script for camera position before making the variable, so don't mind about that. Okay, so now, oh, I'm sorry, I forgot to make the serialized field transform variable. Okay, so create a serialized field transform variable called camera position. And look, now we have a use for it. So now, that's the only thing that we're going to do. And that's the reason I made a sprite called camera position. Because we used it right here. Okay, now add this camera mover script along with the camera controller script to the player camera, and make sure camera position is set to camera pause sprite. And look, we can't see ourselves, but we can see our shadow. So this makes it a first person experience. And look, if we run off the cliff at the end, we can actually see ourselves running toward it. So now, there's only one issue here that has to be fixed. Look, so let me just run this again. And look, see, when we do this, we see that we can rotate all the way through ourselves. Which is not normal because we can't turn our head like through our stomachs and then see behind us. So we have to limit our visibility area so that we can't have a 360-degree vision. I think we should set it to 180 degree because that will be pretty normal. So let me show you how to do this. It's only one line of code that we have to do for the camera controller script. So in the camera controller script, we have to write just below the Y rotation is equal to the negative of mouse Y. We have to write below that X rotation is equal to mathf dot clamp. And let me explain what this does. Mathf dot clamp clamps the rotation between two different integers. So we write X rotation for the first parameter, which is the variable that we want to clamp between two different values. And then the second two parameters are for what numbers we'd like to clamp them between. So I'd say negative 90 and positive 90. And remember, separate them with commas because they're parameters. So this clamps it between negative 90 and positive 90, which gives us a 180-degree turn. So that will be pretty normal because we can look up, we can look down, but we can look straight forward, but we cannot look through us. So let me just run this now. And look, we can look up, then we can look down. We can't look all the way through us when we go down though. So we've added the first person aspect. There's only one thing left to do, and that is jumping. Up till now, we've not covered the basic player movement jumping. So we will work on creating this script, and this will be inside the player movement script. And what do you think we should do first? What do we usually do first in our scripts? We even did it today. We find an axis. So you should probably know how to find an axis. Let's find one. This doesn't seem the correct axis because the positive button is wrong. So let's find the proper one. It should have space as it. I could change this, but I think there'll probably be a right one, so I don't want to change this. Okay, there, I found it. The jump button with space. Okay, so now let me introduce you to a new type of things called headers. Now, let me show you what headers are. So, types of two square brackets like you're about to type serialized field, but in it type header, and then with parentheses and quotation marks, and inside that type the name of our header which I'll name movement. Okay, so now that I've named it movement, we can see in our Unity editor that every variable under it will be called movement. So let's paste all of these. So that's the way headers work. And make sure under your headers you do not have a semicolon because headers don't take semicolons. So now let's create a serialized field float called ground drag. This will be for our jumping, one of our main jumping variables. Now let's create another header. And this one, we're going to type ground checker. And you can put spaces because headers are allowed to have spaces. Now let's create a serialized field variable. And this one is going to be called, let's see. It's going to be called player height. And now let's create another serialized field variable. And we're going to call this layer mask ground layer. So layer mask is another type of variable. So like float, but it's kind of different, but it will help us a lot in our jumping script. So call it a layer mask, and so ground layer will be the name. And now let's create a private boolean or bool and call this is grounded and save all of this. So now we're basically finished with all of our scripts for today. And in the next episode, we're going to make this jumping script work. So you don't have to worry about setting these variables because we're going to do all of that in the next episode. So we can just save this Unity project and also make sure to save your scripts. And you can see in our we can see our headers in the Unity editor. See, in big bold letters it says movement. And it also says ground checker. Okay, so that'll be all for today. Thanks for watching this video. I hope you found it informative. Let me know what you thought of it in the comments section below. Be sure to subscribe and click on the bell icon so you never miss a video. There's a new feature on my channel called memberships. If you would like, you can pay a small amount of money each month to get access to exclusive features, such as members-only videos and exclusive access to videos before they go public. There are several other perks that you could get. Just check it out by going on the join button in my channel if you would like. Have a wonderful time!